So when we have parametric equations, we want to talk about how to find the area underneath the curve. So let's say I have a curve that's given by some kind of parametric equations. X is f of t, y is g of t, and I have some kind of restriction. T is between alpha and beta. So normally when you find area under a curve, your area, you just integrate your function. So this would have been the area formula you saw before, but now we replace y with g of t. Dx gets replaced by f prime of t. And now my bounds will be alpha to beta, but there is one small little catch here. Depending upon the direction of the curve, this integral could be a negative number. And remember, area is a positive measurement, so it could be possible that you have these bounds in the wrong order. Could be beta to alpha. One of these will give you a positive number, and one of them will give you a negative number. Since area is positive, you should use the one that's going to be positive. So let's look at an example. Let's find the area under the curve x equals theta minus sine theta, y equals 1 minus cosine theta, where theta goes between 0 to 2 pi. So let's set up our area equation. Area is the integral from 0 to 2 pi. And then you're going to take y, 1 minus cosine theta, and then take the derivative of your x equation. Well, the derivative of that will be 1 minus cosine theta. And now you need to FOIL that out. It'll be 1 minus 2 cosine theta plus cosine squared. Now we've got to remember how we integrate trig functions. I can integrate 1, I can integrate 2 cosine theta, but this cosine squared, the power is even, so we have to use those double angle formulas that we used back when we learned how to integrate trig functions. 1 minus 2 cosine theta plus, this is 1/2, 1 plus cosine of 2 theta. So if I combine this 1 and this 1/2 together, that would be 3/2 plus cosine of 2 theta and a 1/2 in front. And now I can integrate these things. I can get 3/2 theta minus 2 sine theta plus sine of 2 theta over 4 from 0 to 2 pi. And then plug in 3/2 times 2 pi minus 2 sine 2 pi plus sine of 4 pi over 4. Well, I get 0 there. Sine of 0 is 0, so these are also going to be 0 as well. And you just get 3 pi. So that's the area.